Hello students, welcome back. Dr. Mandis here. Today I'm talking about electrolysis reactions. Electrolysis reactions are a second step in our electrochem series. Last time we talked about galvanic cells, and we drew this pretty little picture of a galvanic cell. And in the galvanic cells we talked about how electrons flowed in the spontaneous direction. In this case they went from the anode to the cathode. And I just want to pose a question to you of what happens if you want them to go the other way. You really want it the other way, you know? You want, instead of cathode, anode, you want all that to change around. So the thing that you have to do is you have to remember that, hey, electrons are going from high energy to low energy. What if we made this side high energy? If we did that, then they would flow in the way we want them to flow. So what you want to do is you're going to go down into your galvanic cell and we're going to introduce a power supply, okay, so to speak. And in that power supply, then we're going to add power to force the reaction in the other direction. Your car engine does this through your alternator. Okay, the battery produces electricity running in the spontaneous direction. Your gasoline acts as a power supply and forces it back the other way and recharges your battery. So every time you recharge a battery, you're kind of doing this. All right. So what you want to do is look for, when things have power source, they're probably going to be the non-spontaneous version of things. If anyway, well, the spontaneous, non-spontaneous version. But anyway, electrolytic cells are used all the time. One of the ways we use is typically they're making metal solids from metal ore, like aluminum ore contains aluminum 3 cation. They add electricity to it and they produce aluminum out of it. It's one of the ways that we get aluminum. Aluminum isn't really found in nature. To do the calculations to predict how much mass of metal you form, it really boils down to 4 different conversion factors. The mole ratio of the metal to the electrons, the molar mass of the metal, a new thing called Faraday's constant, which is basically the charge per mole of electron. If you're on my class, I give that to you in a test. Don't bother memorizing it. And there's a thing called amps. Okay, amps is coulombs per second. It basically is your current. It says how much charge is flowing by per second. Fast current is more, slower current is less. So amps is basically how much charge per second. And the thing is, you have to just recognize that when you give an ampage, it's really coulombs per second. Here's our example of what we're talking about. Here's our electrolytic cell. Alrighty. In our electrolytic cell, we have 2 platinum electrodes. We have a copper 2 solution, 1 molar copper 2 solution. Alrighty. And in there, we're producing copper from one electrode and oxygen from the other. We don't really care about the oxygen right now. Basically, what mass of copper is going to be produced over 2.5 amps is applied for 10 minutes. Okay. Well, you have to recognize what's going on. So usually, most of my students, when they see the ampage and the mass, they say, hey, this is our conversion factor gig. And you're right. I'm going to sketch it out for you. If you're going to go from 600 seconds to some amount of metal, in this case copper, you know that this has to have seconds on the bottom. You know that this zone over here has to have grams on it. Okay, the grams of copper, grams always goes with moles. This has to be moles of copper. So if that's moles of copper, you know that this has to be moles of copper. So what goes with moles of metal? Well, grams, but if you remember our things, the other one was the mole ratio. Well, this can be moles of electrons. Don't worry how many, just know that it's moles of electrons. Well, that means up here in our scribbling, we have to have moles of electrons. Well, that's Faraday's constant. That's coulombs. The thing that goes with seconds is coulombs. So if you look, we got seconds canceling seconds, coulombs, coulombs, moles of electrons cancel moles of electrons, moles copper, moles copper. We're good to go. Here's the more beautiful version down here, written a little bit more neatly. You have your ampage, seconds canceling seconds, 2.5 coulombs. We now have Faraday's constant, coulombs canceling coulombs. We then want to have the mole to mole ratio to cancel out the moles of electrons. That introduces moles of copper. And so finally, in that last one, cancel out the moles of copper through the molar mass. It's a lot of conversion factors, but don't let it bog you down. Sketch an idea out and then make it pretty. Hope you learned something today. Hope you like it. We'll practice more of it. I'm Dr. Mandis, and I'll talk to you later.